Good morning, everyone. Welcome, day 3 or day 4, depending on when you started. So I'm Parashar Shah. I'm a senior program manager with the Azure Machine Learning team. And in the next 20 minutes, I'm going to walk you through the new Azure Machine Learning SDK, which we launched on Monday as part of Azure Machine Learning. And essentially, my intent is to help you get started with it and also showcase the different features and the capabilities of the SDK. Okay. So what are we going to do? Essentially, the SDK allows you to use your existing environment, right? Primarily for Python. And then you can run the machine learning model experiments the way you would do it, and then add the SDK pieces to it, do the experiment tracking, and then deploy the model. So we are going to go through each of these steps one by one. The SDK itself, you can install it in any of the IDEs which support Python. It's basically a pip installable package. But all the demo that I'm going to show you is going to use Azure Databricks. But you are free to use any other Python IDE of your choice. Okay? So let me quickly give you an overview of what Azure Machine Learning is, and then where the SDK resides, right? So the first layer over here is what we call as the pre-trained AI. And it essentially is the cognitive services, or basically there are APIs which you as an AI developer can use to create AI apps. You do not need to know machine learning for this first layer. So if there are use cases around text analytics or vision or even search, you can actually use one of these 30+ APIs out of the box. But then there can be scenarios where these pre-trained AI or the pre-trained APIs do not help you, right? So these could be custom scenarios where you have some domain-specific thing that you are doing. And that is where the next 4 layers come in. So this is essentially the custom AI part of it, where you use a framework of your choice, or basically any library from the open source world or even your own library, as long as it's a Python package. Then you can choose an IDE of your choice. So like I mentioned earlier, you can use Azure Databricks, VS Code, Jupyter Notebook, PyCharm, whichever IDE you want. And then you can use a compute of your choice. So what I mean is that not everything needs a GPU for training, or not everything needs, or not for every use case, CPU may not be the best type of compute, right? So the idea is that if you are creating your own machine learning models, you should be allowed to have the flexibility in terms of what type of compute you choose. So basically, it's a CPU-based compute or a GPU-based compute. And also the flexibility in terms of how many nodes you want. So it could be a single node, like a data science virtual machine you could use for that. Or you could use a batch AI cluster, right? And this cluster can be configured for auto scaling. So that flexibility you have. And for any of these, like basically creating that compute, the SDK allows you to actually create the compute from within your Python environment. So you don't have to go to the Azure portal or things like that. You have an option to do that, but it's not mandatory. Okay? So you can remain within your Python environment and keep doing what you are supposed to. The other part of the compute is the FPGA part, which is primarily used for inferencing or scoring. So once you have a machine learning model that is trained and you want to deploy it in production, again, you have different options for the compute. So it could be, again, a CPU-based compute, a GPU, or FPGA, especially for inference. So FPGA allows you to actually have a very low latency when you are doing that scoring or prediction. So that's the benefit of it. And in terms of deployment, the SDK allows you to, so the machine learning model that you create, actually, we containerize it, and that can be deployed as a web service. And it can be deployed in any environment that supports Docker runtime. So it could be on-prem, it could be in the cloud, and we have 2 options like ACI and AKS. Or it could be on an edge device as well. So Monday and Tuesday, there were a couple of sessions given by my team, essentially, which also talk about edge and all those. So if you want to dig deeper, then you can watch those as well. I have a slide later on. But this is the summary. And Now we are going to actually jump into the demo where I'm going to walk you through on how to actually create a custom machine learning model and deploy it in the cloud. So primarily the 4 layers, what you see over here, that's the focus here. Okay. So let's jump into the environment. Now, I already have a Databricks workspace that was created before that. Now, if you would like to know more about Databricks, we have around 24 sessions going on at Ignite. But to give you a summary, it's basically a collaboration environment for data scientists to actually create machine learning experiments, share it, and then in terms of compute, you have the flexibility of choosing Spark, underlying Spark as a compute, which is, again, a cluster-based compute. Or from within Databricks, actually, you can submit remote experiments to a DSVM, Data Science Virtual Machine, or a batch AI cluster. So the SDK gives you all the flexibility to do local training on Databricks, or you can actually spin up another cluster outside of Databricks and train it remotely and then bring back the results. So you have that flexibility. Now, in this Databricks workspace, so I have my cluster which is running. And this cluster essentially was created with the latest stable runtime of Databricks. So it already has Spark installed. And it also has the latest Azure Machine Learning SDK installed. So you see over here where I have a Databricks-specific SDK, which is there. It's part of the library. And I also have certain custom libraries. So these are some of the libraries which my experiment uses. So I, as a data scientist, want my environment to have these. So I don't have to, like anytime the cluster restarts, I don't have to reinstall this manually. It's automatically taken care for you. Okay. So this is in terms of the environment creation, and it is very easy. So you go to your workspace, basically, and then just say import library, select Python, because the Azure ML SDK, it's a Python package. And you have to just say Azure ML -SDK and Databricks. And then just select install. Now, I have already installed it earlier, so we don't need to install it. But once you install it, the cluster will have that. The other option to install the SDK is if you are using, say, for example, a non-Databricks environment, any Python environment, then the way you would do it is just install it as a pip package over here, where you just say pip install. And if you already have installed it, you add the upgrade keyword to it. Otherwise, just say pip install Azure ML SDK, and then just give this. So it will install it in your Python environment. So these are 2 ways of installing the SDK. And like I said, I'm going to focus on Databricks today. So let's continue with Databricks. Once you have the SDK installed, what you can do is you can actually do machine learning the way you are normally used to doing it. So essentially, get your data from somewhere, create a machine learning model, and then the SDK will also allow you to deploy it. Now, when you actually use the SDK, we allow you to create a shareable entity, and we call it the workspace. What the workspace does is it has 2 components to it. So one is a logical component. So the logical component is it brings together all the compute, the data, and all the models together. So when one person shares that workspace identity with another person in the team, he or she can easily reuse all those things. Okay? And the other part is actually a physical entity where we create a bunch of stuff in the background. So these are things around key vault, storage, and the batch AI compute cluster. So I'm actually going to run this so that you can see how easy it is to get started. This all uses Python as an environment. So as long as you know Python, you are good to go. The things that are required is you need to provide an Azure subscription, a resource group. So resource group is a logical entity. So I assume if you have used Azure, then you are aware of the resource group concept. And then this is the workspace, which I said. So essentially, this is the shareable entity. Now, you saw that in a few seconds, it actually ran it. I had created it earlier, so it just does an update and fetches the latest information. Now, once it gets created, you can either go look at the workspace details in your experiment, or you can go to the Azure portal. And you will see here all the stuff around experiments, compute, model, image, everything is available. So this is on the workspace. Now let's actually start training an experiment, right? So the first thing in creating your own machine learning experiment would be to bring in your data, right? So you prepare the data, you create your model, and then you deploy in the cloud. So I already have the data over here. So this particular experiment, it looks at the demographic data from a census, and in terms of age, the gender, and work hours and things like that, and it tries to actually predict the income of an individual. So that's the data about. I already brought the data, and then you can actually look at what the data is, and then I have split the data into a training set and a test set. Right? So when you are doing machine learning, you need to have two different types of data sets. One is a training, which is actually which you are going to use to train your model. And the second part is the test data, where once you have the model trained, you are actually going to test it, that how good or bad the model is, so you can iterate. And this iteration part is very important, and that's where the Azure Machine Learning SDK helps you, because when you are doing multiple runs of this, we actually log each and every run. So let's actually go ahead and train a machine learning model. So it takes a minute or so, so I'll start it and then let it run. Now, what it is doing in the background is actually, so this is my training code, and then here I'm logging the metrics. So in this case, for every run, I'm logging that what is the accuracy, what is the ROC curve, and what parameters I'm using for that particular run. So every iteration is logged, and it is, while it is running, you can actually see that it has started giving results here. But you can also see that it's actually started giving results in the portal as well. So this is the same workspace which I showed you earlier. And then once it loads, you will see that I have this experiment running over here, number 13, right? And when I go inside it, actually I can see individual runs. So there is a run which is running, and it hasn't given me the metric yet. So let's see what it was. Yeah, so it actually gave you the metric, right? So I was logging this metric from within my experiment, and now it is recorded for me to see whenever. And this can be shared across the team as well. Okay, so this is a key benefit over here of using the SDK. Now, I think it's almost done. And once it's finished, you will see that the model is available. And then I get the best model. So in this case, I'm trying to find out the machine learning model which is giving me the best ROC curve, and that's the best model. So the SDK actually allows you to query. So in this case, I have only 2 runs, but you can actually have hundreds or thousands of runs, and you can just say, give me the best model from this run, and we will fetch the model for you. And this is the model that now you are actually ready to deploy in cloud or edge or on-prem anywhere, right? So we will now look at the deployment piece of it. It finished the training, and it is now doing the evaluation. So it came up with some predictions, and essentially these are coming up like, okay, based on this demographic data, is the income greater than $50,000 or less than $50,000, right? So I'm happy with this prediction because it is giving me like 89% ROC, which is good for this experiment. So I'm going to go ahead and deploy this in the cloud and create a scalable web service. So for creating this web service, you actually don't have to like create or learn Docker or things like that if you don't want to. We make it very easy for you. So what you have is the machine learning model which we trained just now. So that is this circle. Now you also have the option to bring your model that was trained outside the SDK. So if you did something outside the machine learning SDK world, you can even bring in that model. Or you can even bring in a model using the cognitive services, which I showed you earlier, vision and things like that. What is required after that is you register the model. So when I say register the model, it's essentially in your workspace, you say that, okay, this is the machine learning model which I'm interested in deploying as a web service in Azure or wherever you want to. So that is the registration part. You provide a scoring file. Now, what is a scoring file? Scoring file is essentially initializing the model and then tells Azure that, okay, this is how I want you to predict based on this model, because we won't know what your model is doing, right? So you have to write that piece of code, which is essentially that if any data is coming, do something with that data, send that data to the machine learning model, and give back the data. So it's as simple as that. And this is all JSON, so you have to just send JSON data, and you get back a JSON response. And then once you have these two, we help you create the container, and then it can be deployed in either a cloud device or an edge or a light edge as well. Once it's deployed, you can actually look at all the metrics. So how is your model performing? And all this can be logged. So this is all integrated into application analytics. So you can look at the latency, performance, if there are any failures. And this service can be scaled automatically. So now if the data scientists have created a model and the DevOps folks have to deploy it, they don't have to actually worry on figuring out what would be the throughput and all those things. We take care of it for you. So you can auto-scale. It can be auto-scaled based on what is the CPU or the memory load which is coming on that. Okay? So now we are going to walk through the code for this. Now, again, this is the same workspace we use for training, right? So I'm just reading again the information for that. This part is the registering model, and you can actually give descriptions to it. Now, every time you register the model and create an image, we create a version of it. So there can be multiple models and multiple versions of the same model in a workspace, right? And each one you can individually deploy it or based on how much. So we give you all the flexibility in terms of that. This is an example of the score file. So my init function is basically just initializing the model, and the run is doing some transformation and actually doing the prediction. And one key piece over here is we give you the flexibility to create a custom environment of your choice for deployment. So when training, you might have used certain libraries or packages which are specific to your machine learning model. It would be tricky if you had to create the same in the deployment environment. So we make it easy for you. So you just say that, OK, I need these 3 additional libraries, and these get installed every time you spin up a deployment environment. So it's basically containerized, right? So it's a container, and we create it for you. And this is registered in the Docker registry as well. So you can download this image anytime. The next part is actually creating the container service and then deploying the model. So it's as easy as that. You just say deploy from model, and then you just provide that, OK, where is the model, what is the scoring file, what is the configuration I want, and that's it. So in 10 to 15 minutes, you have a web service that is running. Now, you see over here that it took like 12 minutes, so I'm not going to run it right now, but I'll just do the scoring over here. So this is my data, and I'm going to see how well it scores. So I think it takes 2 seconds or so. Yeah, so it gave me the results. So this is the model we trained just now, like 10 minutes back. And it's actually giving me the results now, saying that, OK, out of these 5 records which you had sent, 3 of them have an income less than $50,000, and 2 of them have greater than $50,000. So, and then you can export this in Power BI or any visualization dashboard or whatever you want to. Okay, so this is how it is. Now, the next part is actually deploying the same model to a Kubernetes cluster. So with ACI, you tested your web service. It is working fine. So now you want to deploy it in a production environment, right? And it can be auto-scaled. You can monitor all the metrics and all those. So that's where the AKS service comes in, which is the Kubernetes service. So again, I don't have to repeat whatever I did. I can take the same image. So if you see over here, I had the image which was trained earlier. And you can list all those images, and you can pick the version. So I'm going to pick, say, for example, version 3. It's already deployed. This one takes a minute or so to deploy it. And once you have it, again, just like ACI, you have an AKS-based, so a Kubernetes-based scalable web service available. Now, this can be protected through HTTPS. So it can be a secure endpoint. And there are service keys, so you don't have to worry on that part as well. Now, once you have this service deployed, you can actually now start looking at the metrics. So I have this service running for a few hours now, and you'll see that I'm able to see actually the number of total requests which are coming to it, what is the latency when this request came. So basically, this is last 1 hour's data. But if I go back and see 3 days, for example, you can see it should load quickly. And while it's loading, so this is using application insights. So you can use it in Power BI as well, and wherever you want to export it. I think there's some network connectivity issue, but yeah. And then the last piece of the demo, I think I'm done, but there is a session on AutoML. So what AutoML does is, or automated machine learning does is, when training the model, actually you had to specify which model you want to train, right? With automated machine learning, actually we help you in just providing the data set, and then you tell that, okay, I want a model with the best accuracy, and you give a constraint like, okay, I want to spend 2 hours of my compute time for training it. So we go through multiple iterations and then actually give you the best model out of it. So here I have already trained the model with these constraints, and then it went through a lot of machine learning models over here based on the constraints I gave, and then give you the best result. And this model can, again, it's registered and deployed the same way we did the income prediction stuff. So there is a session on this at 12:30 in W214. If you are interested, it's a 75-minute session where we'll be going through details of this. Okay, so I'm out of time, so just one summary slide in terms of what was showcased. So what you saw, that Azure Machine Learning SDK helps you with end-to-end machine learning when doing custom AI. So you could you benefited it in training locally or remote. You logged your experiments. You can revisit those experiments anytime. And then once you find the best machine learning model, you can actually deploy it in a cloud. Okay? These are the sessions which might interest you. So a couple of them happened Monday, Tuesday. There are a few planned today and Friday. So that's it. So thank you very much.